Simplifying rational expressions. First of all, a rational expression is a quotient of two polynomials. Basically a special kind of fraction, so a lot of properties of fractions will apply to rationals. Just like fractions, we always simplify a rational. So the steps to simplify a rational, we need to begin by completely factoring the numerator and denominator, and then simply cancel out any common factors that the numerator and denominator have in common. So example 1 basically is only one term. So just a review of how to simplify a fraction. Reduce or cancel common factors. So 10 and 25 obviously reduces to 2 over 5. X to the 5th over x cubed, quotient rule of exponent. Subtract the numerator's exponent from the denominator's exponent leaves us an x squared in the numerator. A rational will have more than one term in the numerator and denominator. For instance, if you jump down to example 3, obviously you see some plus or minus signs, which means more than one term. So this is an example of a rational where we'd have to simplify by beginning to factor. Now in example 2, the factoring's already been done for us. The numerator has two factors, two things being multiplied. The denominator has two factors, two things being multiplied. So in order to reduce or simplify this rational, we simply cancel out any common factor. So an x minus 3 in the numerator cancels out with an x minus 3 in the denominator, leaving us the remaining factor x minus 9 in the numerator and the x plus 3 in the denominator. So at this point it's completely simplified. Students will have a tendency to try and cancel out the x's at this point and maybe reduce the negative 9 over 3. Where we were able to do that in example 1 when it was only one term. But since we're working with more than one term, every single term in the numerator and denominator would have to have that common factor, which of course is not the case. So at this point, we are completely simplified. So example 3, simplify the rational. Begin by factoring the numerator and denominator. Well, the numerator obviously is already factored. The denominator factors into x plus 2 times x plus 2, or you could write it as x plus 2 squared if you want. So that one x plus 2 in the numerator cancels out with one of those x plus 2's in the denominator. When factors cancel out, what you're left with are 1, so that leaves us 1 over 1 times x plus 2, or simply x plus 2. Example 4, simplify the rational. So once again, begin by factoring. The numerator factors into x plus 3 times x plus 4. The denominator, x plus 3 times x minus 8. So common factors cancel out, leaving us the remaining rational, x plus 4 over x minus 8. Example 5, still simplifying, so factor the numerator. Don't forget, follow all the same factoring steps. It's in standard form. Always check for a greatest common factor, which is 3 in this case. So continue on factoring. 3 times x minus 7 times x plus 5 in the numerator, all over x minus 4 times x minus 7 in the denominator. So the x minus 7's cancel out, leaving us 3 times x plus 5 over x minus 4. Number 6, simplify the rational. Well, the numerator is already simplified, already factored, The denominator, though, is a trinomial where a is not equal to 1. So this is where we want to split up that middle term into two separate terms, allowing us to use the grouping method. In order to do that, multiply a times c together. So 4 times 9 gives us 36. And write the factors of 36 that we can combine to get 9, which would be 3 times 12. So we're going to rewrite that middle term, 9x, split it up into a negative 3x and a positive 12x. Allowing us now to use the grouping method. Factor out the greatest common factor from the first set of parentheses, x, leaving us 4x minus 3. The next set of parentheses, 3, leaving us 4x minus 3. So at this point, factor out that 4x minus 3, leaving us x plus 3. So it's completely factored. We see no factors cancel out. So it was already simplified. Next, since these rationals are fractions, we know we're never allowed to have a 0 in the denominator. It's considered undefined, so we always have to be aware of any values that may make a denominator equal to 0. So determine where the following functions are undefined. In order to do that, just take the denominator, set it equal to 0, and solve. So example 7, x minus 5, set it equal to 0. Gives us a real simple equation. Solve for x. X is equal to 5. When x is equal to 5, there will be a 0 in the denominator, as we see if we evaluate the function at 5. 5 over 5 minus 5 leaves us 5 over 0, which of course is undefined or does not exist. So number 8, notice we're not simplifying. We're just determining where the function's undefined. So just take that denominator, set it equal to 0, and solve. It factors into x times x squared plus 12x plus 20, which factors further into x times x plus 2 times x plus 10. Set each factor equal to 0. X is equal to 0, x is equal to negative 2, and x is equal to negative 10. 3 values that would make that function undefined will give us a 0 in the denominator. Example 9, same thing. Well, in this particular case, it wouldn't make any sense to try and set the denominator equal to 0. We wouldn't have a variable to stand for, to solve for, so there are not any values that would make this function undefined, which makes sense because we don't have a variable down there. It doesn't matter what we substitute in for x, the denominator will always be 3. It's a constant.